So students, in the last lecture I have discussed the part on straight lines. So today I'm going to start circles. This chapter is quite big, but you need to have patience to complete the overall chapter with full emphasis, right? So let's start the circle. What is a circle? We in the previous lecture on straight line I have discussed one important term, locus. Whatever I can wait a bit. Locus. What is locus? Locus is a path followed by a moving point, or a path of a moving point. This is called locus. So our topic should be on circles. So what is a circle? A locus which is equidistant or a path of a moving point which is equidistant from a single point. Suppose a path of a moving point like this, which is equidistant from a single point, this, suppose this, that single point, this single point is known as center, right? I am saying again, locus, point or a point, a path of a moving point which is equidistant from a fixed point, right? Equidistant from a fixed point. So the fixed point is known as the center, and if we close the curve, then the whole closed curve is known as circle, right? And the distance on the point of the circle to the radius, right, to the radius is the, to the center is the radius of the circle. You have heard the term radius from the very beginning of your small classes. So today I am going to start with how to build the equation of a circle. Suppose this is a circle. If we draw a circle in a coordinate axis, then we will be having then we must have center have some coordinate, and the any point on that circle may have some coordinate. Let us consider this coordinate of the center is hk, right? And the any point on the circle, just wait a bit, and any point on the circle, let us consider P, and this is denoted by xy coordinate. Then what will be the distance of radius? From distance formula we can say h x minus h whole square plus y minus k whole square, or x minus a, squaring both sides we get this is the equation of a circle with radius r. Suppose the center is origin, The center is origin. If the center is in origin, then hk will be 0. That means equation transforms into x square plus y square is equal to r square. Clear? So let's go to the next slide and continue. I don't know you have heard about second degree equation or not, but let me discuss it precisely. A second degree equation is oftenly written as, suppose, wait a bit. My second degree equation is written as ax square plus by square plus 2hxy plus 2gx plus 2fy plus c equals to 0. This is the second degree equation. This equation at different condition we are going to get different curve, that is parabola, and at some condition we are going to get the equation of ellipse. So there's no issue. But for circle, what is the condition? Condition is this part should be 0. There is no term xy should be present, implies h equals to 0. And the second condition is that a must be equals to b. The coefficient of this x square and the coefficient of y square must be equal. These are the two conditions that should be followed for a circle if it is written in second degree form. So suppose equation is given like that. Suppose the equation is given like this, then you should convert it into this type of form. I have written in the previous slide this type of form. So make whole square like this. So what you get, just check, you are getting like this. So from here, if we compare with this equation, we can say that center is hk. So the center will be -2 -3, radius is 2 unit. And from the second degree equation, if a b equals to 1, suppose considering a b equals to 1, then equation changes to 2gx plus 2fy plus c is equals to 0. If we write in this manner, then you will see the equation is converting like this. This equation is coming from the second degree equation. From here we can say that center is minus g minus f coordinates, and the radius is wait a bit, it is having some problem. So I have to write again. Some problem is created. So I have told that this is the center and the radius is 2 unit, right? I'm just fast forwarding my process. If this I'm just writing. So if we compare with respect to this, then I can say that center is minus g minus f and the radius is root over d square plus f square minus c. This is the way we are supposed to find the equation of a circle. So please change this one, please. This is minus, right? Let's go to the new page. So you have found that radius, if you square the radius, you will get like this. If this value is greater than 0, then it implies the radius greater than 0, that is this is real circle. If radius equals to 0, then it is called point circle. Point circle. If radius less than 0, then it is called imaginary circle. So if a circle passes through origin, suppose like this. I'm not good at drawing, but still trying. Suppose the circle is like this, then the constant term is always 0, right? Suppose the circle is touching x-axis. Suppose the point on that x-axis is let h0, then the circle center will be h, and r, let the radius be r, y distance is r, and the x distance is h. The tangent of the circle is also, we can say, the x-axis. So from here you can, if I write the equation, then it will be like this. Clear? If a circle touches y-axis, suppose it is touching y-axis, then let us consider this is 0k, then the center will be rk. Then we can write the equation like this. Clear? The first one is the circle touches the x-axis, and the second one is the circle that touches the y-axis. You are going to have another type of equation of a circle that comes from the diameter form, right? So if the two ends of a diameter coordinates are given, then you are able to find. So I am writing at the top diameter form. What is diameter form? Suppose a circle is given. Suppose this is the endpoints of the diameter, and the coordinates are suppose x1 y1 and x2 y2. Let us consider a point P lies on a circle. Right. Let us consider point P lies on a circle across across any ends of a semicircle, or across the arc of the semicircle. So we always know that the angle in a semicircle is 90 degree. It is known to you. I am writing just a minute. Angle in a semicircle is 90 degree. If this angle is 90 degree, then suppose this is point A, this is point P, then we can write slope of AP cross slope of PB is -1 from the straight line, from the condition of two perpendicular lines, you know that. So from here what we can write, y minus y1 over x over x1 into y over y2 x over x minus x2 equals to -1. From here what you are going to get a equation like this. That is x1 x2 or y1 y2 are the coordinates corresponds to the endpoint of the diameter, right? If that points are given, then the equation of the circle becomes this one. Suppose a circle that intersect y-axis at 2 points. Suppose this is a circle that is intersecting at A and B. Suppose it is intersecting x-axis at A and B, right? Suppose the coordinates of A and B are x2, 0. Then if I write the equation of a circle, suppose the equation of a normal circle is this, as y is 0, circle that the 2 points on the circle lies on the x-axis. So to find that AB length, or you can say the intercept length, this AB length is known as intercept length, x intercept length, x intercept length. How to find that? X intercept length is x2 minus x1. So whenever y equals to 0, then the equation transforms like this. a quadratic equation, if the quadratic equation has roots x1 and x2, suppose, then x1 addition of the root is equals to always minus b by a, you know that, and the multiplication is c by a. So if you find the subtract value, suppose mod value, or you can say this one is x1 minus x2 mod value, you can say, then it will be x1 plus x2 whole square minus 4 x1 x2, like this, you know, have a root over here. If this is the way, then what will be the x1 plus x2 whole square, that is 4g square minus 4 of c, take 4 outside, then it will be 2 root g square minus c. So the formula is the intercept length, x intercept length is 2 root g square minus c. So in the similar way, if you need to find the y intercept length, suppose like this, suppose like this, this is like this, y intercept length, suppose, let us consider, if y intercept length, then just instead of g, that will be f, 2 root f square minus c. You can solve it on your own. The same way, here it will be x equals to 0, and you are going to get the value of y1 minus y2, right? So the next topic is parametric form. So let's go to the new note and discuss the parametric form of a circle. I hope in straight line you have gained some knowledge about parametric form. So let us do on circle also. Suppose a circle is remaining like this. Suppose the HK is the center of the circle, and any point on the circle is xy, you know, and this angle is suppose theta. So if I make a zoomer view of that circle, then what you are going to get, and like this, suppose O A B, this one is theta, and the radius OA is r, then this will be r sin theta, and this OB will be r cos theta from right angle triangle ABO, we can say. So if the coordinate of O, that is center, is HK, then how to write the coordinate of A that lies on a circle? For x coordinate, it will increase from h plus r cos theta. So h plus r cos theta, and the y-axis, it will be k plus r sin theta. This A, which is defined by some trigonometric angles, this is known as parametric form, right? Parametric form. So x is h plus r cos theta, y is k plus r sin theta. If you need to get this, then you can also write like this. You will get the same equation that I have done in first slide, right? So if suppose, let us giving an example. If the equation is like this, suppose 7 square, then parametric form will be 3 plus 7 cos theta y is 4 plus 7 sin theta. Clear? So now the remaining part of today's lecture will be what will be the position of a point with respect to a circle, and that position, if it lies outside, then what will be its minimum distance from the circle, right, and the maximum distance. So let's go to the new note and conclude. Position, first is position of a point, right? Position of a point to a circle with respect to a circle. Suppose a circle is given, equation is x square plus y square plus 2gx plus 2fy plus c equals to 0. So suppose a point P, where it will lie, how can you say it is lie inside of the circle or outside the circle? Suppose, just for showing, I am suppose writing P outside the circle. Suppose the coordinate of that very point is x1 y1. So to know what should we perform, if we see, suppose this is S, if we see the value after changing x to x1 and y to y1, if the value is coming to be greater than 0, then it lies, P lies outside the circle. I am writing, suppose this is a specific value 4 3, suppose this lies outside the circle. 2gx1 plus 2fy1 plus c greater than 0, it implies P, it is lying outside. Clear? If it is less than 0, implies P lies inside, and it is, if it is equals to 0, then lies on the circle, P lies on the circle. Clear? So this is much easier. You are going to get many more questions on that. So the next topic is maximum and the minimum distance. On the minimum distance, of a point, suppose A, B is the endpoint of the diameter. Suppose the point is xy and this is R and the center is minus G minus F. Then what will be the maximum distance of a point from the circle? The maximum distance is AP from the just opposite ends. If AP, then it is R plus, if this one is M, MP, that means root G square plus F square minus C plus root X plus Z whole square plus Y plus F whole square. For the minimum distance, it will be PB, and you can easily calculate PB. This is MP minus r, this is x plus z whole square plus y plus f whole square minus r. If the maximum distance and the minimum distance is added, then obviously the radius gets cancelled, right? Obviously the radius gets cancelled, that is you are going to get this and this, right? So in the next lecture we are going to have some concepts on tangents. So today this is the final part I have discussed. In the next lecture I am going to cover tangents, normal to a circle, chord of contact is there, intersections of circle, directed circle is also there. I guess I will try to complete all the topics in the next lecture with a short description of each and every topic. Whatever the part is needed, I will go through in details. Thank you.